Welcome to Open Pakistan Education Network. Introduction to Machine Learning. It is fairly common to hear about AI and machine learning these days. But very few know what it actually is. Artificial intelligence, in reality, is a very broad topic and encompasses both machine learning and deep learning. We are going to focus on machine learning in this discussion. Data is at the center of machine learning, and the amount of data in the world doubles every 2.4 years. This data is either collected from social media like Facebook, Twitter, or YouTube, or from various web applications or mobile apps. Data can be collected from a variety of sources. These sources of data can either be public or private. Example of public sources include those where data is available to general public without requiring any credentials to access that data, such as Twitter. Example of private sources include those where only a select few have access to the data, who have the necessary credentials to access that data, for example the national identity card data stored by NADRA. The first step in a machine learning workflow is to ingest the data. What ingest essentially means is that data is collected from multiple sources where it resides. The second step is called staging, where the collected data is copied to a central location, prepared, and made available for use. To stage the data means data preparation, cleansing, and munging or wrangling. This leads to the staged data, or a portion of the staged data, to become a dataset. Just to be clear, a dataset is data that has undergone cleansing, integration, transformation, and dimensionality reduction. Data cleansing or cleaning involves filling in the missing values. Whenever a dataset is generated or exported from a database, it may contain some missing values. The first step of the data preparation process is making sure all the missing values in the dataset are filled with meaningful values. The second step of data prep is integration, which implies merging together different existing datasets to form a new dataset. The third step is data transformation, which means adding new or removing unnecessary columns or duplicate rows from the dataset. Step number 4 is dimensionality reduction. Each column in a dataset is known as a feature or dimension. Feature selection, which is a part of dimensionality reduction, involves picking only those columns or features that are related in some form or fashion to the problem at hand. Once the data has been staged, the next step in the machine learning workflow is to train the model with the dataset. The staged database is prepared to create a dataset. The dataset is then used by several machine learning algorithms for training ML models, and a machine learning model is selected based on its efficiency and accuracy. Coming back to the machine learning workflow. The last step is to deploy the model. Deployment of a model entails making it available to other applications and processes for use, whereby new data is submitted to the machine learning model for evaluation to get a prediction result. To summarize, the machine learning workflow comprises the 4 steps: ingest, stage, train, and deploy. Machine learning involves taking a dataset and applying some operations or algorithms to create a model which can then be used to make a decision or get an insight. The focus here is to use the operations or algorithms to create a model. These operations or algorithms is also called model creation or model training. Before it can be evaluated with new data, a machine learning model must be created or trained. The objective of machine learning is to have the ability to classify, or predict, or to identify trends or patterns in the data. The key phrases here are classify, predict, and identify trends or patterns. We will now look at each one in detail. To classify some information into some predefined categories, a machine learning model is trained using a dataset, and each record in the dataset is manually flagged as being in Category A or Category B. An example of this is animal classification, where a model is trained using pictures, and each picture is flagged as being of a cat, or not a cat. Once the machine learning model has been trained, a picture of a cat passed to the model will be evaluated and predicted to be from a cat. However, an arbitrary picture is evaluated or classified by the same model as not a cat. An example similar to animal classification is skin cancer identification. A machine learning model is trained with pictures of skin cancer, which are manually flagged as either a cancer diagnosis or not cancerous. So when the model is used to evaluate a new skin image, it can be used to diagnose whether a patient has cancer or not. Another classification example is of breast cancer identification. A model is first trained with patient data to classify a diagnosis. The same model can be used to evaluate a new patient's data to make a diagnosis. Not all machine learning problems are used for classification. Some of those problems involve prediction or forecasting. For example, a model can be used to predict a numerical value, the rain in inches in Karachi. The dataset used to train the model is the historical data for rain in Karachi. Machine learning can also be used to predict how many runs a team will score in a Pakistan Super League or PSL match. A machine learning model can be used to predict or forecast a numerical value, or total runs scored by them, based on a model trained with historical score data for that team. Lastly, we will look at how a model can be used to identify trends or patterns in data. When a machine learning model is trained, it is done by applying an algorithm to a dataset. The applied algorithm is used to identify certain patterns in the trained data. A good example of this is the categorization of animals for the Eid al-Adha sacrifice across the country in Pakistan. The data is collected by gathering the information of all the economic activity in Islamabad, Karachi, Lahore, etc., and money is transferred to the rural areas of the country. Moreover, the government of Punjab has supposedly built a blockchain solution that tracks the sale of sacrificial animals across the province. The data is collected for the entire country in a centralized dataset. The features for the dataset include animal weight, origin, total toll paid, distance traveled, sold or not, Eid day sold, original price, final sale price, etc. These features are used to categorize sacrificial animals in various classes. Each category signifies a class that can be traded during Eid.